Hello and welcome to arc length. All right, let's start by saying, well, what do we mean by arc length? Arc length for this particular sector here would be the distance on the circle itself from these sort of outer points. So we're talking about this distance here. All right, I could even label these points. We're talking the distance from A to B, and it's on the curved part of the circle. This angle here is called the sector angle, and I've drawn this circle to have a radius of r. Now, how do we find arc length? Well, we use two equivalent ratios, and the first ratio has to deal with the sector angle. So what we do is we say, well, the angle of that sector, okay, proportional to the entire angle in the circle. Now, if we're talking about the full angle of a circle, it's kind of like the biggest sector possible in a way. It would be 360 degrees. Okay, so we're saying sector angle compared to full angle of a circle. That ratio is going to be the equivalent of the arc length AB compared to the full arc length of a circle, which is another way of saying the circumference of the circle. And the formula for that is 2 pi times the radius. So these are equivalent, and this is how we solve questions that involve arc length. We basically put our two ratios together, and then we go a-solving. So let me do an example of that right now. So let's say we had a circle, and let's draw the sector in the circle that we are given. So somebody comes along and says, oh, let's make the sector angle 80 degrees. All right. And in addition to that, somebody says, oh, this is no ordinary circle. This is a unit circle. Now, what does that mean? A unit circle means it has a radius of 1. Okay, so whenever you see unit circle hidden in the question, it gives you that extra bit of information that the radius is 1. And we are asked to find this arc length, which I will call x. So all the information is there, and it's actually a pretty easy question, because you go, well, sector angle is 80 compared to the full angle of a circle. So that comparison will be the same as the arc length for this sector compared to the circumference of the circle. So that's my two ratios, and it allows me very easily to solve for x by cross-multiplying and then dividing. So 2 pi times 80, and then divided by 360. Now, I'm going to actually just not bother with my calculator. I'm just going to simplify this and leave it as an exact number. So 2 divides into 360 very nicely. Then we could divide each of these by 10, so we can get rid of those zeros. And then I got 8 over 18. Well, I can divide each of those by 2, so that would be 4 over 9. And don't forget, you still have the pi up here. So there is the length of x left as an exact number, or this is often referred to as a fraction of pi. So a fraction of pi. It's kind of like saying a piece of pie. It is a fraction of pi. All right, now on to my second example. So that's all there is to this one. This one is done. In the next example, we have the following. We have an 80 centimeter diameter wheel. So 80 centimeter diameter wheel. And we are going to rotate this wheel, rotated through 400 degrees. Okay, so that's what we're told we're going to do. And what's the distance covered by the wheel? Distance covered. All right, so now let me show you how we think our way through this. Okay, what you got to visualize. So let's draw a little wheel here. And let's start off with a simple little sort of comparison. So there's our little wheel. And let's say now it has a starting point, say, right here. Let's say that's where our radius is. Okay, so that the radius is sort of like touching the ground right here. Now suppose I rotated this thing through 90 degrees. So let's say we're rotating the wheel like this. Okay, so it rolls forward along the ground thusly until we get over to here. So let's see if I can draw this in the right spot. Oops. Uh-oh. Don't worry, I'll move my wheel. Okay, I hope. Let's see if I can move my wheel. All right, well, some parts of the ground. Well, anyway, it doesn't really matter. There's my wheel. Now, here is this part here, the radius kind of got also rotated up like this. All right, so say it'd be rotated to there. Now, this would have been a rotation through 90 degrees. So originally we were here. Now we've rotated it through 90 degrees. And the distance covered would be this part here until we get to there, right? That would be the distance covered. Now this is only rotating through 90 degrees. But here's what I want you to see. Isn't this distance along the ground, if you picture this wheel rolling, isn't that exactly the same as this arc length from here to here? I mean, really, when you think about it, I know my drawing doesn't really do it justice, but if you picture rolling this wheel through that 90 degrees, then this little guy here, this arc length, is what's kind of making this distance across the bottom. So really what this question is saying is we're going to have a sector angle of 400 degrees. See, here it was only 90 degrees. So we're going to have a sector angle of 400 degrees. And we want you to figure out what is the corresponding arc length. Really, that's what the question's asking. And once you recognize what the question's asking, it's not really a hard question. I think it's the thinking through what are we supposed to do here. In the end, not too bad. Just be careful. If the diameter is 80, that means the radius is 40. Okay, so now it becomes an easy cross multiply and divide. I'm going to go to solve this 2 pi times 40 times 400, all divided by 360. Now, you can either leave your answer as an exact number if you want, which just means to simplify this fraction. You know, you can do a few simple things like 40 goes into 369 times. So you could leave this, if I look at what I got here, I don't think it simplifies anymore. I could just say 800 pi over 9. But that doesn't look too good. So it's actually better in this case because it has a contextual problem. We're talking about finding an actual distance. I think you're better off to just do it on the calculator and approximate it and say, well, I got 279.25, and these are centimeters. So that would be the distance covered if you rolled this particular wheel through an angle of 400 degrees. And that is where I'm going to stop talking about arc length.